For this lecture, we are going to talk about immersive reality or extended reality, XR. Actually, extended reality is a combination of both virtual reality and augmented reality. As technology evolves, it gives new shape and meaning to reality, offering up new ways of looking at and understanding objects, spaces, and environments. Many different industries and types of businesses are harnessing reality technology to improve and expand operations and to drive growth. In the construction industry in particular, reality technologies hold significant promise, helping teams increase accuracy and confidence during planning and construction, as well as improve communication and collaboration on both the worksite and in the office. The technologies currently used in construction workflow include virtual reality (VR), augmented reality (AR), and mixed reality (MR). Jointly, they are referred to as extended reality or XR. By helping the various stakeholders involved in a project to quickly and easily visualize and explore designs, models, and site conditions, XR is changing the way construction is done and improving workflows across the building and infrastructure lifecycle. As XR technologies continue to gain prominence in the construction industry, the stakeholders like contractors and consultants will need to have a baseline understanding of what the technologies are, how they can be used, and the benefits that they can provide. XR technology as a whole allows construction professionals to more easily visualize, understand, and communicate information. Each tool by itself helps the construction teams to see digital content in different ways and for different purposes. For example, XR technology just doesn't make it easier to visualize design. It can also be used to virtually see behind walls and under floors. This capability enables crews to pinpoint the location of underground services, for example, or identify equipment or building maintenance issues. The ability to immerse someone in a virtual environment has other significant implications, such as making it possible to train workers in hazardous materials handling in the context of a safe and controlled environment. XR is not just about the wow factor or the latest gadget. The use of XR is helping construction companies to solve major challenges, enabling them to, number one, foster better stakeholder engagement by improving communications and collaborations along the design chain, the construction chain, and with the owners. Number two, achieve greater productivity by accelerating decision-making, reducing downtime, and minimizing rework. And thirdly, to improve safety by facilitating through planning and training. Traditional 2D plans are difficult for many people, including laymen and professionals, to visualize. XR can literally bring these plans to life, so both internal and external stakeholders can clearly understand how the finished project will be positioned and how it will look and function in the real world. XR can also be used to clearly communicate design intent to the external stakeholders, increasing support for the project and even become a competitive advantage for the contractor. By providing stakeholders with a visual representation of the project before construction, challenges can be identified and communicated more easily, ensuring expectations are effectively managed. XR also makes it possible to share work in progress in a safe and yet realistic manner, a critical capability for those who must manage complex public projects involving multiple stakeholders. Similarly, XR makes it possible to share design intent with the internal stakeholders. Work crews, subcontractors, and others on the job site gain a single and consistent visual representation of the finished project. When everyone from owners to public officers to contractors to subcontractors are working from the same understanding, they coordinate and communicate with each other more effectively. XR creates a shared vision for the project that in turn increases likelihood of success. As the current labor shortage in the construction continues, companies are having to make do with the resources that they have and make more efficient use of their time. XR tools get everyone on the same page quickly by enabling a common and accurate understanding of the design and the site conditions. By providing a visual representation of the project in context, XR helps project teams estimate, plan, and schedule the work in a more confident and with more precision. Project teams are using XR application for crash detection, allowing them to uncover potential issues before the building begins, and minimize the potential for expensive rework that can erode profits and delay schedules. With fast access to accurate and consistent information, project teams can streamline construction workflows, stick to the timelines, and avoid undue confusion and disruptions. When XR is used in combination with BIM, teams gain even more efficiency. They are able to access and share integrated data and in the context of the design. With a clearer understanding of the design intent, they are able to make better and faster decisions informed by reliable and consistent data. Construction is one of the most dangerous industries, accounting for 1 in 5 workplace fatalities in the US. In fact, it is estimated that 2 workers per day die in construction accidents in the United States, and thousands more are injured every year. The data is pretty similarly dire in Singapore. The repercussions of fatalities and injuries cost the industry billions of dollars annually. Yet, accidents and near misses can be minimized with thorough planning and a clear understanding of the potential risks and threats. XR can help to bring these threats to light. For example, construction workers can use VR technology to visualize what's underground before excavation work begins. They can use this information to avoid costly utility strikes, as well as to know where to divert workers or the public to keep them out of harm's way. XR technologies are also being used with models of real-world sites to review safety hazards. These models can then be used for safety training and to inform workers of the hazards. These benefits alone are having significant positive impacts and delivering a sizable return on investments for those who are already using XR technology. While more difficult to measure, the ripple effect of better stakeholder engagement, greater productivity, and increased safety can be expected to produce even more profound shifts and create momentum to bring about broader industry transformation with so many acknowledged is needed. Let's look into the area of virtual technology. Let's look into the history of virtual reality. The term virtual reality was coined in the year 1987. But actually, as far back as 1935, there was a fictitious book that was published about virtual reality. In 1957, the first virtual reality multimedia device was created. And 4 years later, in 1961, the first head-mounted virtual reality display was also created. And 5 years later, in 1966, the first basic flight simulator was designed and created. In 1968, the first head-mounted VR, AR display came into the market, and 10 years later, the first virtual remote travel experience was brought to the market. In another 8 years' time, in 1986, VCASS, Advanced Flight Simulation Program, was launched. And in 1991, we have the first virtual reality arcade games. And along the way came Nintendo, the Virtual Boy portable device in 1995. Subsequently, along the years, there are different developers that push their products into the market. And by the year 2018, Facebook reviewed the Oculus Half-Dome. So, virtual reality got its start in the gaming industry by immersing players in artificial worlds, wearing special goggles that removed the real world around them and projected a virtual reality instead. Players become part of the game and were able to interact and respond within it using natural gestures and movements. VR goggles, regardless of their use in gaming, construction, or other industry, operate using the same principles. Motion sensors in the hardware detect when the wearer turns their head. The digital image the user sees is then updated accordingly to present new perspective. At the same time, handheld device allows the user to point and interact with virtual objects. Because VR provides a fully immersive experience, it is an especially effective tool for design teams, contractors, and owners to review and approve plans and understand sites and spaces. The VR application controls the entire environment that the user sees, creating a uniquely detailed and dynamic individual experience. Here are some examples of how to use VR. Owners can fully immerse themselves in the proposed design of a building that doesn't exist yet and see the concepts taking shape. A team member that may not be located at the job site but wants to understand the actual site situation can virtually experience a scanned 3D model of the site in the office and then is able to communicate more effectively with his fellow colleagues in the field. Construction contractors can also use VR technology to train workers on specific tasks in a safe environment, such as how to use heavy equipment or install electrical wiring. Most of the VR applications at the moment provides an individual experience rather than a group one, so users won't be able to see or interact with other people in the room beyond a digital representation of them in the VR environment. Because VR is a fully immersive experience, the user can't see the real world around them. It is also best to use it within controlled indoor spaces so users can safely move around and avoid potential hazards. While VR's applications are limited by this constraint, it is well suited to office demonstration, presentations, and training. In the future, as our technology increases, we will probably be able to come up with a VR experience that allows more than one party to join in the particular experience.